Hello again. Welcome to Chapter 7.5, Dilution of Solutions. In a dilution, this is actually something that you guys have probably all done yourself, but basically what is happening is that water is being added, so volume is increasing, and the concentration is decreasing, but the mass of the solute is remaining the same. So this is why the concentration decreases, because the solute is remaining the same. Okay, so remember, our ways to express concentration and what concentration is, it's giving us a way to express how much solute is present in our solution. You guys have probably all done this yourself. So if you were to add a can of orange juice concentrate to a glass pitcher, and then you dilute this orange juice by adding water. So you add, say, 3 cans of water or 4 cans or whatever it might be, but here it's 3. And so you end up mixed together, you have diluted your 1 can of orange juice now to 4 cans of orange juice by adding water. So you do this the same with, making tea, or if you want to dilute say you make some sweet tea and it's too sweet for you. So you can add some more water, so you dilute that sweet sugar taste, and it's not as sweet. So there's a calculation for diluting, and we can use our concentrations and the volumes related to these, and we can solve for volume or concentration of a solution once we have diluted it. And you see this represented as C1, C standing for concentration. So these are the values that we discussed in the last section about mass, or volume, or mass-volume, or molarity. One that's very common is seeing the M1V1 equals M2V2. Okay, that uppercase M here is the molarity. Okay. So this large M here is molarity. Okay, and so all you have to do is plug in the variables. So you have to be given 3 of the 4 variables, and you solve for 1. If we were asked, what is the final concentration when 0.50 liters of 6.0 molar HCl solution is diluted, so the key word here is diluted, this is where you want to think about this equation, to a final volume of 1. Okay, so let's be sure, so we can use M1V1 equals M2V2, or you can use C1V1 equals C2V2. Okay, just to be sure, I don't know if I said this on the last slide, I think I forgot, that your C1 stands for your initial concentration. Your V1 stands for your initial volume, C2 for your final concentration, and V2 for your final volume. Okay, so sometimes you even see these written as CI, VI, CS, VF, standing for initial and final. Okay, so that's the same for your molarity here as well. You have a 1 for your initial, and the 2 is for your final volumes and molarity. So if we set up kind of a table here, our concentration to begin with is 6. That's given to us there. We're asked for the final concentration, so that's C2. That's what we're trying to solve for. Our volume to begin with is 0.50, and then by diluting a solution, you add more. So our final volume is 1.0. So basically, it's been doubled. Okay, you can basically just rearrange the equation to solve for what you're trying to find. So we're trying to find C2. So if we rearrange here and we isolate C2 by itself, basically you're moving your question mark, or what you're trying to find, isolate it by itself on one side of your equal sign. Okay, and then you're just going to plug in the values. So we have 6.0 molar, just to save time, I'm not putting units here, times 0.5 divided by 1.0. Okay, and so what we're looking for, we are looking for C2. Okay, so we know our units are going to be molarity because we have concentration. Okay, so 6.0 times 0.5 and divided by 1. Okay, this equals 3 molar HCl. So we can find what the molarity of a solution will be. This is very useful if we dilute our original solution and its concentration gets diluted. We can find what the new concentration would be. We can use this same equation when we're using different units for concentration. So all the ones we discussed in our section 7.4. We're using our mass volume units for this problem, and we want to know the volume of a 2% HCl solution prepared by diluting 25 mils of a 14% mass volume HCl solution. Okay. So if we look here, we can write out C1 and this time we're looking for V2. We're asked for what volume can be prepared. Okay, so we're looking for V2. So if we isolate V2 by itself, go ahead and rearrange. It'll look like this. Okay, and you can write out, if you want to, in a little table, what's your C1, your V1. But as you get, used to doing these problems, you can just plug in the values from what's given to you. So our concentration for our C1 is going to be 14%. Our volume is 25. And we are going to divide by 2. This should give us 175 milliliter solution. So here's our C2, our C1, and our V1. We can do this yet another way with different units. So really, it's the same way as far as the same equation, but we can use different units. Now we've got our mass volume. What is the percent mass volume of a solution prepared by diluting 10 mils of a 9% NaOH solution to 60 milliliters? Okay, so we're looking for our C2 again. So if we rearrange, look at this. Our C1 is 9% NaOH. We're starting with 10 milliliters. You're always going to be starting with a smaller volume than your final volume because you're diluting, you're adding water to it. And we have 60 milliliters as our V2. So when we do the math here, we should get about 1.50% mass volume of our NaOH solution. And we'll just do one more with molarity because this is the most common way to express concentration. But basically for all of these, you just plug in the variables into your equation, and it doesn't matter what the units are. For molarity, you just plug in, for concentration, you just plug in the number that's given to you, and it doesn't matter, what units they are. You don't have to convert anything. But in the end, if you're solving for molarity, then your units will be whichever units you had in the problem. Okay, so this one, you want to try to do this by yourself and then see if you get the same answer. Okay, so molarity, remember, is equal to moles per liter. Okay, but here we're not concerned with that. We know that that's what molarity is. I want to be sure you guys remember that. We're asked for the molarity, so we're looking for M2. So if we rearrange, look like so. We're given 0.600 molarity. We multiply this times V1. So it's going to be our smaller of the two volumes we're given. So we're given 0.180. And our V2 is 0.540. And if we do the math, multiply the two numbers on the top, divided by 0.540, get 0.200 molar nitric acid solution. And this concludes video on molarity and all of the ways that we can express concentrations. Thank you.